You are welcome back to this channel. So in today's class, I want to show you how you can derive formula for finding the inverse of 2 by 2 matrix. In set of real numbers, we know for each non-zero real number x, there exists x inverse, that is x raised power minus 1, such that x multiplied by x raised power minus 1 is the same thing as x raised power minus 1 multiplied by x, and it will give us 1. So we call this x raised power minus 1 the multiplicative inverse of x. So that is the multiplicative inverse of x. So this is true for real numbers. It is also true for matrix. What do I mean by that? If I have matrix A, and if I have the inverse of that A, multiplication of matrix A by its inverse, if it is the same thing as multiplication of inverse of A multiplied by that A, and it gives me an identity matrix, then I can easily say that this A inverse is the inverse of matrix A. Now, let A be equal to A, B, C, D. So let A inverse also be equal to X, Y, Z, W. So we want to check whether if we multiply the two together, we're going to get identity matrix. So what we're saying is that if we have A multiplied by A inverse, is it going to give us identity matrix? So let's check. So if I have A multiplied by A inverse, is going to give me A multiplied by A inverse will be equal to A, B, C, D multiplied by X, Y, Z, W to be equal to 1, 0, 0, 1, which is a unit matrix, or you call it an identity matrix. Now, let's perform multiplication of matrix A. So A multiplied by X will be equal to AX plus B multiplied by Z, that is BZ. So this one multiplied by this. Then I have A multiplied by Y, that is AY, plus B multiplied by W, that is plus BW. C multiplied by X, that is CX. Then plus D multiplied by Z, that is plus DZ. And I also have C multiplied by Y, that is CY, plus D multiplied by W, that is plus DW. So this matrix is equal to 1, 0, 0, 1. So this is where we're coming from. This is where we're coming from. So from here, I can now say that my A multiplied by A inverse is equal to, from here, I can say that AX plus BZ is equal to 1. So I have AX plus BZ to be equal to 1. So let me call this one equation 1. I can still say that AY plus BW is equal to 0. That is equality of matrices. AY plus BW is equal to 0, equation 2. Then CX plus DZ is equal to 0. CX plus DZ is equal to Then cy plus dw is equal to 1. Cy plus dw is equal to equation 4. So from here, I can now let's look at them. You know, I have ax plus bz, I have cx plus dz. So I can take them together. So I can say I have ax plus bz is equal to 1, equation 1, and cx plus dz is equal to 0, equation 2. So this is equation 3. So I can bring ay plus bw is equal to 0, which is equation 2, with cy plus dw, which is equal to 1, and it is equation 4. So now I want to make x the subject of the formula here. If I want to make x the subject of the formula, that means I need to multiply equation 1 and equation 3 by 2 constants, so that this side and this side will be the same thing, because I want to isolate x. So how do I do that? I can say that let's multiply equation 1 by d, and we are multiplying equation 3 by b. So this is what I'm saying. So we are multiplying this side, everything here, by d, and you are multiplying this side also by d. So it multiply everything here by b, then multiply this one also by b. So what does that give me? I can now say that I have ADX, that is D multiplied by AX, plus D multiplied by BZ. BDZ is equal to 1 multiplied by D. So let's do it for this ones also. So I have BCX, then plus BDZ is equal to 0. You can see I can easily eliminate BDZ now. So let's call this one equation 5 and call this one equation 6. So from here, I can say that subtract equation 4 from equation 5. That is equation 5 minus equation 6. Yes. So I have ADX minus BCX plus BDZ minus BDZ is equal to D minus 0. So from here, you can see I have positive BDZ, then I have negative BDZ. So they have cancelled each other. So I am left with ADX minus BCX to be equal to D. So I have ADX minus BCX to be equal to D. That is D minus 0 is equal to D. So from here you can see that X is common to both of this expression. So I can factorize X out now. So I can have AD minus BC multiplied by X is equal to D. So I can make my X the subject of the formula by dividing both sides by what? AD minus BC over AD minus BC. So AD minus BC cancel AD minus BC. So now my X is equal to D over AD minus BC. So I have gotten the value of my X now. I can find Y as well. How do I do that? So I'm coming to equation 2 and equation 4. So I want to make Y the subject of the formula. Now, it means that I'm going to eliminate everything that will be in this side and this side, so that I will be left with this A and C, Y. Now, what I'm going to do now is that I am multiplying equation 2 by D. So, multiply by D. So, I am multiplying equation 4 by B. So, this one multiply by B. Now, I have ADY plus BDW is equal to 0. Then I have BCY plus BDW is equal to B. So let me call this one equation 7 and call this one equation 8. So I want to eliminate BDW. I want to eliminate them. So how do I do that? I can say that I want to subtract equation 4 from equation 8 from equation 7. So if I do that, I will have ADY minus BCY plus BDW minus BDW is equal to 0 minus B. So positive BDW cancel negative BDW. Now I am left with A dy minus B cy is equal to minus B. I have A D minus BC. So I'm factorizing y out is equal to minus B. So from here I can make y the subject of the formula by dividing both sides by AD minus BC over AD minus BC. So this cancel this. So y is equal to minus B over AD minus BC. So I've gotten the value of x and I've gotten the value of y. So I need to find z and w now. So from equation 1, 3, 2, 4. So let's see how we can do that. So it means that if I want to go to equation 1 and 3, that means I'm eliminating this side. So how do I do that? I'm doing that by multiplying equation 1 by C and multiplying equation 3 by A. So you multiply this side by C, you multiply this side by A. So what do I have? I have ACX, then C multiplied by BZ, I have plus BCZ is equal to 1 multiplied by C. So I also have ACX here. So A multiplied by ADZ, I have plus ADZ is equal to 0. So that means this side is what? Equation 9. 7, 8. Equation 9. And here is equation 10. So from here, I want it to be in form of AD minus BC as well. So that means I am subtracting equation 9 from equation 10. So equation 10 minus equation 9. Equations. This one minus this one. So I will have, so ACX has cancelled each other. So I have ADZ minus BCZ is equal to 0 minus C. So factorize Z out. I have AD minus BC. So Z is equal to minus C. So I can now say that my Z is equal to minus C over AD minus BC. So I have gotten my Z also. So I need to find W. So to find W, I'm going to equation 2 and equation 4. So I'm eliminating everything with the left hand side here. So how do I do that? I'm multiplying equation 2 by C, multiplying equation 4 by A. Multiply by C, multiply by A. So now I have ACY, then plus BCW is equal to 0, and I also have ACY plus ADW is equal to A. So this one will be equation 11 and equation 12. So this is equation 11 and here is equation 12. So I'm subtracting again. So that means I'm subtracting equation 11 from equation 12. So ACY will cancel ACY. So I have ADW minus BCW is equal to A minus 0. So let's factorize W out. So I have AD minus BC multiplied by W is equal to A. So from here, I can make my W the subject of the formula by dividing both sides by AD minus BC. So I have W to be equal to A over AD minus BC. So my X is equal to D over AD minus BC. So recall the determinants of 2 by 2 matrix. So determinant of A, recall that our A is equal to A, B, C, D. So its determinants will be what? You are multiplying elements in the leading diagonal, which is A multiplied by D, minus multiplication of elements in the second diagonal, which is B, C. So if you look at the denominator of X, Y, W, Z, you can see that they are all in form of AD minus BC. So I can easily say that my W is equal to A over determinant of A. My X is equal to D over determinant of A. My Y is equal to minus B over determinant of A. And my Z is equal to minus C over determinant of A. Now, what is now our A inverse? The A inverse that we have the other time, our A inverse is equal to X, Y, and Z, W. So let's substitute these values there. So A inverse will now be equal to our X is what? D over determinant of A. And Y is equal to what? Minus B over determinant of A. Z is equal to minus C over determinant of A. And W is equal to A over determinant of A. So from here, I can factorize determinant 1 over determinant of A out because it is common to them. So I can now have my A inverse be equal to 1 over determinant of A multiplied by D minus B minus C and A. Can you see we have gotten the short method that I taught you in the other time in the first video. That is, I taught you that if your A, you can quickly do it this way. If your matrix A is equal to A, B, C, D, the first thing that you need to do is that go and find the determinant, and determinant is what? AD minus BC. So after doing that, the elements in the leading diagonal, let them be interchanged. So you have D, then A. Then the elements in the second diagonal, put negative sign for them. So you have minus B, minus C. So now the inverse of your matrix now will now be equal to 1 over your determinant multiplied by D minus B minus C A. So that is how they got this formula from. So I just want you to know how it is derived. That is why I make video on it. But if you want to do it, that the short method is the one that I will advise you do. That's it. So you don't need to derive all this one. I just show you that this is how it was derived. So if you want to find determinant inverse of 2 by 2 matrix, let's say we have matrix. So let's do example 1. So if matrix B is equal to 3, 5, minus 2, and 1. So find B inverse. So solution. The first thing is that we need to find determinants of B, which will be 3 multiplied by 1, 3, minus 2 multiplied by 5, that is minus 10. So I have determinants of B to be equal to 3. Minus multiplied by minus is plus, so plus 10. So determinant of B is equal to 10. After getting your determinants, then you go and interchange the leading diagonal. So our B becomes, or the adjunct of B, let's call it adjunct because we still need it, becomes 1, 3. The leading diagonal elements there are interchanged. So we are putting minus there. So we have minus 5. So minus multiplied by minus 2 gives me plus 2. So now A inverse will now be equal to 1 over determinant of A multiplied by adjoint of B. So the adjoint of B is this one. So now my A inverse will now be equal to 1 over 13 multiplied by 1 minus 5. So B inverse. So the formula for B inverse now will be equal to 1 over determinant of B multiplied by adjoints of B. So now our B inverse will be equal to 1 over 13 multiplied by the adjoint of B is 1 minus 5, 2, and 3. So if you like, you can leave it like this. If you like, you can simplify them, but it is advisable for you to leave it like this. So that is how to find the inverse of 2 by 2 matrix.